Hey everyone, thanks for joining this session with me. So my name is Oleksandr Yaremchuk. I'm a principal engineer for LLM security and open source initiatives at Protect AI. Protect AI was founded by the AI leadership at AWS and Oracle after they saw a massive gap in the market when it comes to the lack of security and AI adoption at large enterprises. Today, we raised 48 million, and our team is close to 50 employees across the US and Europe with our headquarters in Seattle. So during this presentation, I'll take you through our journey with LLM Guard. We begin by exploring the emerging threats that are defining the current landscape of LLMs. Next, I'll dive into the creation and evolution of LLM Guard. And finally, we'll discuss the future of LLM security and why traditional methods like firewalls are no longer sufficient. So among the broader trends in adoption across enterprises, LLM adoption has emerged as a uniquely rapid and widespread phenomenon. Early indicators of this trend are highlighted in a recent report by Andreessen Horowitz, which forecasts 2.5 times growth in average investments per company in LLM applications. It's growing from about 7 million in 2023 to 18 million by 2024. Companies are taking different usage and build patterns, being split between using open source models such as Llama 3 and Mistral to API-based models for their internally built applications. With it, they're looking at use cases for employees first, and of course, their customers. Besides that, some of them are also simply procuring enterprise LLM solutions like GitHub or Microsoft Copilot. And I'm sure many of you are aware also of the worries surrounding the unauthorized usage of LLMs on the web by employees. Across the board, companies are adopting LLMs, and they are looking at applications such as enterprise, knowledge management, text summarization, to external chatbots, and recommendation algorithms. In most cases, the prevailing trend was that companies are actually relying on a multitude of models, yet primarily on closed source vendors, and looking to build applications that are internally facing. The obvious reason for that is the primary concern on security and data protection. And that is indeed very much true in what we have seen. Many companies have been rushing to not only build, but ship these novel LLM applications to production. As a result, most of these companies are flying blind and without any security. We see here there are some pretty embarrassing cases of news headlines surrounding that the chatbots that are either creating offensive content, giving false advice, selling cars for just $1, promoting criminal activity, and much, much more. This was all due to lack of guardrailing of these applications, which left them prone to the most basic attacks such as prompt injection and jailbreaks. For those of you who don't know what the terms are, both the prompt injection and jailbreaks are classes of an LLM attack that are built to force the model to take actions that are either outside of its intended or permitted purpose, or simply removes the safety filters. While today such attacks have been relatively harmless and relatively primarily leading to embarrassing headlines and general brand damage, the reason why they're relatively harmless is that most applications are fairly limited in their capabilities. That is beyond the model and the application. They are not yet connected to downstream systems for automations, that is when agency kicks in, or upstream with databases for constant documentation of the prompt with data of the company to get more relevant results. Nevertheless, it still shows us what the future holds. We have slowly started to see real-world ramifications with the lawsuit by Air Canada as a result of false advice. Similarly, researchers have shown what connected system with agency may hold. It was a great example of a self-replicating attack with an email agent. That is when LLM is connected to your Gmail account and spreading the same prompt injection to all contacts for self-replication. All in all, what we have seen here is a general knowledge gap between both the builders of the applications, the security teams, and the GRC teams across companies as to how they can effectively tackle both the need for security and compliance, as well as the ability to keep innovating and competing within the market with this powerful technology. So this slide is a pretty nice overview, and I do want to give kudos to the OWASP team on the LLM security for the basis of this common architecture. It serves as a recap to my previous point on expanding capabilities. As you can see, most of the early applications were primarily limited to LLM, fine-tuning with a dataset from the company, and serving it via an API. While these are already fraught with risks within the input and output, Expanding capabilities with RAG and agency, that is connected systems, will make both the blast radius and complexity of the security of LLMs even more challenging. At the core, however, of securing these applications will always be the input, that is the prompt, and the output of the model, which effectively triggers what comes next across the LLM value chain. Yet again, the core message of this slide is, as we are expanding capabilities of models, we are effectively introducing new potential pathways for exploitation. What we expect to occur more widespread over the coming months as these capabilities emerge are attacks that include gaining access privilege in downstream systems, denial of service attacks, unauthorized data access directly from the model, unauthorized data access from retrieval augmented generation, potential unauthorized data access from the downstream connected systems, integrity breaches undermining the model's original intended purpose. The examples from before pushed the need for inline protection and the rise of LLM firewalls. We have seen 1 to 3 companies get launched weekly since August 2024, when we released the first version of LLM Guard. Some have died, many have pivoted. It was a hype to say the least, and a rapidly commoditizing space. But to switch gears, what is LLM firewall? It acts as a reverse proxy sitting between a user and the LLM that underpins the LLM application, or it's a part of like API gateway in case you have internally developed or deployed models. Every firewall is usually powered by a set of scanners, covering 3 key areas of risks across the prompt or the output, such as data leakage, that is PI, like names, bank account numbers, or secrets, such as like API keys or passwords, adversarial prompt attacks, like prompt injection or jailbreaks, as I mentioned before, and integrity retention of the model application that is detecting offensive content, or your model recommending your customers to go look at your main competitor. LLM Guard is our own open source security toolkit for applications. It wraps security controls and observability around any LLM to address security risks in interaction with them in both the input and output of the model. LLM Guard's primary advantage is its model agnostic approach. This allows us to provide consistent and effective security across a wide range of LLMs, starting like from high-profile models like GPT-4 to more aligned models like Anthropic's Claude and various smaller open source ones. For example, we also tested LLM Guard with Google Gemini model, the Gemini Pro, and we noticed that while their model couldn't defend like against a simple prompt injection attack, even though we put like a special, we provide enough context and guidance, with LLM Guard applied, it could provide consistent security. With deployment options as an API or Python library, it's built to integrate seamlessly into your existing systems. To secure against the risks mentioned before, we have more than 15 scanners for the input and more than 20 for the output of the LLM. These scanners are highly configured to encompass the broadest set of use cases to detect, flag, redact, sanitize, or simply block the prompt or the output when the risk is detected. The library is built in a way that makes it easy to extend with additional scanners for a specific use case. And all scanners generate metrics detailing risks alongside interaction logs. We have over 4 million downloads on our models on Hugging Face. And as we are open source, we don't have always full visibility in like how or where LLM Guard is deployed. However, we do know that security engineers and LLM developers from Google, Palo Alto Networks, Symantec, F5, DataRobot, and other companies have been actively testing, deploying it, and also they are active in our Slack channel. Back in summer 2023, our interest in the AI security space, particularly the open source segment, grew. We believe strongly in leveraging community engagement to shape products. After discussion with multiple companies, we identified a significant barrier: the transition of LLM application from proof of concept to production. A major contributing factor was the lack of robust security, which became our focus. Despite the absence of dedicated budgets for LLM security at the time, AI engineers were actively experimenting with LLM use cases and were increasingly concerned about security implications. When we started developing LLM Guard, there were several open source libraries that were abandoned, and hence were a non-starter to us, to companies seeking for a solution. We looked at them to find a common set of scanners that could act as a strong basis for LLM Guard. That gave us inspiration for the initial 8 scanners we included in our first release. We explored automatic red teaming tools like Garak to understand and defend against potential attacks. This exploration influenced our decision to rely on text classification models and regex scanners. Additionally, we customized existing libraries such as Presidio from Microsoft to suit specific LLM security needs. Following this initial release, we actively collected and incorporated feedback from our community. For example, we merged similar functionalities like toxicity detection, input and output, and removed redundant jailbreak scanner, and many more. One significant community request was for a unified deployment method. In response, we introduced an API that allows companies to deploy LLM centrally, simplifying LLM security management across multiple applications. We also integrated into popular LLM development frameworks such as LangChain, where we are default security scanner for prompt injections, or Llama Index, where we secure RAG applications, inputs and outputs. We further have LLM gateways such as Light LLM that proactively added integration with LLM Guard for their enterprise clients. Recognizing educational gap, we added detailed text scenario descriptions to our documentation. This helps users better understand and select appropriate security measures for their use case. We also found that users care about latency and the cost of running LLM Guard. For that, after experimenting with different options, we decided to provide ONX versions of the models that provides 3 times improvement in the speed running on the CPU while saving cost of not using expensive GPUs. However, with GPUs, the speed can be improved even further. We are constantly working on improving the latency running on CPU by looking at new ways to optimize it. In November 2023, we realized that all the prompt injection models were released in the summer or earlier and became outdated, but still being used in most of the solutions. We trained our own model and received 2.5 million downloads just in the first months of our release on Hugging Face. And recently we released the second version of it, taking all the community feedback to improve the model. Similarly, we found that there is no model to detect that if the LLM refuses to answer, and researchers in their papers use keywords detection like as an AI model, I'm unable to, and so on, which wasn't enough to us, so we trained our own model. And to ensure that LLM Guard remains at the forefront of LLM security, we continuously refine and expand our capabilities. We regularly update our models to stay best in class, for example, to detect PI entities or offensive topics. That also includes proprietary models for rejection detection and prompt injection that surpass the performance of existing solutions. Our development strategy is heavily influenced by ongoing research in LLM security. By analyzing new research papers, we identify potential security gaps and develop targeted solutions. For example, when we found a jailbreak attack using non-English prompts, we built a language scanner that enforces one language in the input and output. When we found that models could produce gibberish or that Unicode characters could be used to prompt inject models, we introduced new scanners to detect and protect against those risks. We also added test cases from different papers to constantly check if we are able to detect those and remain best in class in our capabilities. For example, in the recent OpenAI's paper, there were a couple of cases how they tested for prompt injection. We actually added them to LLM Guard to verify that our model can actually detect such prompt injections. Additionally, being open source, our community helps us by sharing continuous feedback about novel threats, blind spots, so we can cover those gaps a lot faster than our closed source competitors. We further also receive contributions. And we introduced the first public benchmark on Hugging Face to compare our prompt injection model against others on a given prompt. It doesn't just evaluate us against some public data set, but it helps users to check against the real examples that they have. And we look at new automation red teaming tools like PyRead from Azure or Prompt Bench from Microsoft to test LLM Guard against scenarios that they developed there. Yet, the challenge with LLM firewalls is that they miss the bigger picture of LLM security because they only center around inputs and outputs, and they don't provide visibility into downstream security, allowing actions with access privilege beyond input and output. It also fails to incorporate upstream security against unauthorized data retrieval within vector databases or knowledge graphs. A further limitation include the lack of full conversational context, as inputs and outputs are evaluated individually within all existing LLM firewalls. This is an issue as most attacks are successful from few-shot prompting. So you like multiple prompts until, for example, persuasion attack. The final point is that firewalls incur risks or performance degradation in latency and cost when scaled to handle millions of prompts on a monthly basis. As a result, all LLM firewalls face the challenge of dealing with the trilemma of latency, cost, and accuracy. The main reason for this is the fact that real-time scanning for security is expensive if one needs to keep latency low and accuracy high. Most companies even rely on GPUs, which are 3 to 5 times more expensive than CPUs, to compensate for that. But it's just further amplifying the issue. So at scale, the question kicks in for many companies in need of LLM security, how the cost equation will evolve with millions of prompts per month. We even did a basic math exercise of looking at public prices of LLM security companies. We looked at the cost of per call, which reflects one scan of either input or output. We then looked at the cost of running LLM from the case study of Klarna, which they shared publicly, how they improved their chatbot experience with LLMs. And what we learned is that the cost of security by all the vendors with public pricing is several multiples larger than the cost of runtime. As we expect the price per token to decrease even further over time, the issue is likely to expand even further. If you ever evaluate any LLM firewall vendor, I encourage you to do the same exercise. So in summary, firewalls are great, but they face limitations at scale ranging from an unsustainable cost equation to UX degradation, which is related to active blocking as a result of false positives and latency challenges. Finally, most of the solutions are built for technical engineering teams or technical security teams, yet the majority of the market are in fact non-technical security teams in need of more than mere symptoms. Security teams are in need of detection capabilities with remediation steps. We need to be able to map the full scope of the LLM value chain and not be limited to just input and output. And before I head into our thoughts on what the future of LLM security will look like, I want to tell you that we actually been here before. A great example of this problem was put forward by Nico Pop. He was executive at Symantec, who flagged that it reminded him of the CASB times. That is the cloud access security broker. Initially with CASB, real-time scanning for security was the best practice. Similarly, Protect AI CISO, Diana, gave a great example that there was a big debate back in the day on the trade-offs between intrusion detection systems and intrusion prevention systems. But in both cases, the industry very quickly realized that real-time security is not scalable due to the immense amount of interactions the solution will face, which may lead to degradation in the UX and immense cost. We see a lot of parallels based on the publicly available pricing on existing solutions. We have already seen the number of LLM interactions grow from thousands to millions per month exponentially. That is the exact same issue with LLM security. As was then, we now also need to rethink the security model of LLMs by introducing security monitoring solution that is asynchronous with detection and response capabilities to all risky user interactions with LLM applications. And as we expect the volume of prompts, responses, and capabilities of models to expand, we need to be ready to handle the security of LLMs with millions of prompts and outputs per every month. This implies LLM security that can handle multiple modalities, from images to different file types. An example is like a very popular prompt injection attack, like with images, where like you put some hidden text that is like, for example, white on white, or encompass down and upstream challenges with RAG or agency. A shift in the mindset from firewalling to LLM threat detection and response, including for non-technical security teams, is another important point that like we expect to happen. And at Protect AI, we are currently working on addressing those challenges, and we are also constantly working on improving LLM Guard and actually adding more capabilities to it, like with this context. And yeah, thank you all for your attention. I would like to hear your thoughts or answer any questions you might have. Please ask them in the chat. Oh, yeah, I will share the link. Yeah, so LLM Guard is open source. It's multiple scanners, and maybe I can quickly show you. So we have documentation. This is official documentation. We explain different attacks and, for example, classify them according to different popular taxonomies like NIST. And there is also, we mentioned, for example, OWASP in every scanner. We mention, like in prompt injection, we mentioned like how it refers to the most popular these days classification from the OWASP team. Each scanner has a text scenario described, so you can understand better what it actually protects. Then, like, how you can use it, for example, standalone scanner, or you can use it like as a part of like multiple scanners. In addition to that, we also have performance metrics on different popular AWS instances, both the GPUs and CPUs. So you can also select what is kind of the best option for you according to your needs. And also there is output scanners that we have. So we believe that security like should start not just from the input, and input is just not enough. So we also cover the output. For example, there is sensitive scanner, which basically redacts. If it finds like some PI information, it will catch it and redact it. Imagine you accidentally somehow the customer information was leaked to the model, and then somebody managed to extract this training information from the model. This scanner would prevent that. Additionally, we have, for example, the special scanner to ban code. Like, for example, you don't want anybody to leak IP, like intellectual property of the company, which is the code to the model. So we will handle that and do that. Yeah, we do input and output classification by using those scanners. We have more scanners on the output. So they're more like, sometimes they're related to, like, for example, valid JSON or reading time, like, so it's not too long. What is actually quite cool and quite unique, which I really recommend everyone, like, to, for example, for your real world applications to use, it's no refusal scanner. No refusal scanner is cool because it can detect that the model refuses to answer. And for example, if you have like some kind of monitoring dashboard and then suddenly you have a spike of refusals, it means that somebody is trying maybe like to jailbreak the model, like ask some offensive questions, and the model refuses to answer. So you might need to look at, you know, the prompt or like actual user interactions. So we also have like something for relevance, like if the prompt is relevant to the answer, the language, malicious URLs, and a lot of other scanners that we rely on. So those can be used standalone. Each scanner can be used like as a set of scanners. It can be used also as API. We have already like prepared API, which supports like parallel scanning like sequentially. It also has observability. So for example, you can export metrics and tracing to your tools that you use using OpenTelemetry. It's Dockerized, so it's easy to deploy. And we also have page on Hugging Face where we publish our models. They're all open source. So for example, you can use like a prompt injection model and use it for your own purpose. By the way, we also have Playground. So there is in our documentation, there is a Playground which is hosted by Hugging Face Spaces. So you can go there like and play with different scanners, check how they work. And yeah, we also publish best practices, like how would you put it like on production. So it might be helpful when you start like using production environment and then like want to optimize certain things, and like you need some recommendations. Yeah, I'm happy to answer more questions if anyone has them. I will also share with you the benchmark is here. So it's a special application we prepared. So like you couldn't put any, like imagine like you want, sure, like I will answer the data poisoning part 1 second. So we have here like a bunch of different solutions, including open source models, by the way. and let's say you can find like any prompt that you find like a prompt injection, and you want to test how different solutions catch this prompt or not, including actually Azure, Lakera, and others. And you just put it there, and you can check what's the latency, and also is it prompt injection or not. So there is a question about the data poisoning and how do we solve data poisoning. In that case, we solve it by scanning the output. So for example, one solution that we have is the bias scanner. Let's say your like data was poisoned like just by being a bit like toxic, let's say, a bit biased. So bias scanner in that case can help, or there is dedicated toxicity scanner that also helps with that. Additionally, we have relevance scanner that kind of like if it's poisoning that, like for example, your model answers with completely unrelated stuff. There was recently, I don't know if you saw it, but there was like a problem in OpenAI when the model started producing gibberish. So we created a scanner for that case as well. For example, like model just produces random text. We can catch this, and for example, like you can use it as like monitoring solution. And then in parallel, when something goes wrong, you will catch this. Like the banned topics, for example, you put certain topics that you don't want to be mentioned there in the input or output, and then the model can basically check for those things as well. Hope I answered the question. Any more questions? Okay. Okay. How about jailbreak? Yeah. So jailbreak, like we initially had a dedicated scanner for jailbreak attack, which was basically we took like all the common jailbreaks attacks on the internet, put them in the file, and then like do some kind of similarity scanning. Then in the first version of our model, we actually embedded classification of jailbreaks inside that model. And later, what we did is that in the second version, we actually removed jailbreaks from the classification data set. So the thing about jailbreak is that the common examples on the internet, like Dan, AutoDan, and so on, most models actually can catch them. Quite simple, like Anthropic or OpenAI, they will catch them. So what we are focused on how we can catch jailbreak indirectly. Like instead of just classification models, we are trying to catch it like with other ways. For example, language same scanner. As I mentioned before, there is a common jailbreak that everybody uses is like ASCII art. Like for example, somebody like instead of saying like how to make a bomb, you like draw it with ASCII characters. Or you say it like in Japanese. So for example, model was not aligned well on Japanese, so you say it in Japanese. Or like there are like a lot of different ways. So to prevent that, we kind of try to enforce the model to be in the same language, so nobody will like ask the model to do it in like. Nobody will ask the model to like write in to ask the question in Japanese, for example. In addition, there is also GCG attack where like you have these random characters that you brute force, and then like when you put those characters, the model kind of like will try to. So they're trying to brute force what characters will lead the model to answer with sure it's, and like then the instructions. So in that case, prompt injection scanner actually can catch that. It will catch the GCG attack. We tried in a few cases. Additional gibberish can also catch that because it will see that there is some like random characters that are not really related. There is also attack that was from, if I'm not mistaken, Dropbox. So what they did is they tried to like repeat the same. So there is tokens, and there is this tokenization, which is using tick token library. And if you take like some token and then repeat it many times, like the model can be jailbreaked. We are trying to actually like build a scanner that will kind of go and see if somebody is trying to like put certain token many times. So that's like pending. It's going to be in the future versions. Yeah, if anyone has more questions about LLM Guard or like just LLM security in general, I'm happy to answer those. Okay, I think. Okay, yeah. So if you think about if you think of any questions later, feel free to email me as well. I'll share my email here, Oleksandr@protectai.com. Thanks everyone for like being on the session. Thanks for joining, and thanks for your questions as well. Enjoy the rest of the event.